welcome you to this morning's session on hot topics in health. For the next 90 minutes, we're going to have a series of conversations with three distinguished panelists who work here at UNC. Because our time is tight, I'm going to give a brief introduction to each of them in the order that we're going to be conversing. And we've envisioned this as sort of like a fireside chat, but no fireplace today. So our first speaker is Dr. Gwenn Garden. She is chair of the Department of Neurology and the H. Houston Merritt Distinguished Professor of Memory and Cognitive Disorders. She is also co-director of the Duke-UNC Alzheimer's Disease Research Center. Dr. Garden completed her undergraduate education at Northwestern University and received her MD and PhD in physiology and biophysics at the University of Washington. She undertook her residency and a research fellowship at Brigham and Women's Hospital and the Longwood Neurology Training Program in Boston. Prior to joining UNC in 2019, she was on the faculty at the University of Washington, where she served as vice chair for 7 years. She is an active clinician, researcher, and leader in the fields of neuroinflammation, neurodegeneration, and dementia. Our second panelist is Dr. Samantha Meltzer-Brody, the Assad Mamende Distinguished Professor and Chair of Psychiatry. She also directs the UNC Center for Women's Mood Disorders and is an executive sponsor of the UNC School of Medicine and UNC Health's Well-Being Initiative. She received her BS in Biology and Psychology from Simmons College and her MD from Northwestern University Medical Center. She pursued a residency in psychiatry at Duke and served as a Robert Wood Johnson Clinical Scholar at UNC. She is the recipient of many honors, including the O. Max Gardner Award, which is the highest ranking faculty award among the 17 universities. And in 2021, she was named to the Forbes list of women over 50 working to improve our collective mental health. Our third guest is Mr. James Rosen, who goes by Jimmy, and he is the inaugural CEO of the rapidly emerging antiviral drug development initiative known as READDI, which is based here at UNC. Mr. Rosen provides a wonderful example of the different paths our careers may take, especially when one's interests intersect with health and business. He graduated from Duke with a BA in public policy and has completed a dual degree program here at UNC with an MBA in business and an MPH in public health. During his career, he has worked in various clinical, research, and financial positions, both in the healthcare and biotechnology sectors. He spent several years on Wall Street and where he was an equity research analyst, and has worked in the area of venture capital at Intercept Partners, the Bill and Melinda Gates Foundation, and was CEO of Artisan before joining READDI. So, let's get started. Dr. Garden, we recognize that our bodies change as we age. We certainly don't look the same as we did when we first came to Carolina 50 years ago. Can you tell us a little bit about what's going on in our brains? Tell us what's normal and what's not normal.
Should I use
I think that's
Okay, so we're good. It's definitely on. Okay, so I have a few slides. I'm not sure where to point this. This way goes.
Back there, up there.
It was working this morning.
That's not the right one. Nope, that's not.
Nope. Sorry.
Okay, well, we can talk about.
There
we go.
That's it.
There we go.
There we go. Yep.
That one before.
There we go. Your brains.
Yes, well,
There
we
you go.
can start there, actually. That's great. We'll go back to the list, I think. So you can get their MRI scans of the brain, and on the right-hand side, I guess it's my right-hand side, why is this one, is the normal brain, what it looks like in an MRI. And all of us as we age, our brain tissue starts to shrink. And so you start to see more black space around the brain, and that's normal aging. Now, it's all about the amount of shrinkage and where the brain starts to shrink that we start to have what we call pathologic brain aging. And as you can see in the middle one, often when people develop something we call minimal cognitive impairment, or MCI, you may have heard that diagnosis, you can start to see some specific shrinkage in the area of the hippocampus, which is this area of the brain that's really important for memory. And when the hippocampus and other areas of the brain around it start shrinking faster and more extensively than would be expected in normal aging, that's when we start to have memory problems, and maybe, and we don't always know this, may be a sign that Alzheimer's disease is coming. So that's I guess one of the things to think about, as signs that I often speak with families to look for, where we say it may not be normal brain aging, is one key one is if you are having trouble not just remembering where you put something, but that you put something, right? So you can say, I can't remember where I put my phone, but I know I put it down. But if you can't remember that you had your phone earlier in the day and you put it down when you came back from walking your dog, that's a little bit more concerning than if you can remember you had your phone in your hand, you were walking the dog, you came back, and you don't remember to put it down. Another kind of memory trouble that we get a little bit more concerned about is when you have trouble remembering how to get to a place that you have been before. So, and again, not that, oh, I've been down this UNC campus with all its crazy roads, and I know I have to turn left somewhere, but I don't remember exactly where I have to turn left. That's not, that happens to all of us. We all remember when we were on whatever campus we attended, how long and how difficult it is to learn where every path and every road is. But if you are thinking about going to the grocery store where you go regularly, and all of a sudden you can't remember how to get there, we do get concerned about that as well. And lastly, we get concerned about people having trouble coming up with words, and again, not when it happens to you when you're talking to a big group of people or in an uncomfortable social environment, but when just in your regular day-to-day speech you really have trouble coming up with the words, and this, especially words again that you use frequently. So the 5-syllable word that you can't come up with, or the name that you can't come up with, that's sort of normal aging. But when you're having trouble coming up with commonly used words or creating sentences that are smooth, then you start to worry about that as well.
So I understand that dementia is not one single entity. Can you briefly review the different types of dementia and possible etiologies? And you mentioned mild cognitive impairment, but how much of dementia is genetics versus environment versus lifestyle?
Okay, so there's going to be 2 answers to this question because it was really 2 questions. So one of the things about dementia that's becoming very complicated is with more and more studies of people after they pass away, so autopsy studies of the brain, we are starting to recognize that there are a wide variety of age-related pathologies in the brain. And I've outlined on this slide all of the different abnormal proteins that accumulate in the brain with age and the diseases that they're associated with. The difficulty is that you may come in with some, or bring your parent in, or a loved one, and know that they're having trouble thinking, speaking, finding their way around in the world, doing regular things that they used to be able to do well. And they get an MRI and it shows some atrophy. We still don't know what they actually have, and the reason is because many people have multiple accumulation of these abnormal proteins. So you may have a lot of amyloid, which is the thing we think is the pathology in Alzheimer's disease, and you also may have a little synuclein, which is the protein that accumulates in Parkinson's disease and something called Lewy body dementia. I don't know if everybody remembers Robert Williams got diagnosed with Lewy body dementia. So you may have a little bit of two different things. There's a protein that was more recently discovered called TDP43, which accumulates in patients with ALS in the motor neurons, but it can also accumulate in the hippocampus in a relatively recently described disease that is called late. And that late pathology can also be seen frequently in patients who have Alzheimer's disease, and when the two occur together, people decline at a much faster rate than when they have only Alzheimer's pathology. Interestingly enough, when they have only late pathology, it's actually a very, very slow progression of cognitive decline.
So we see here beta amyloid and tau and synuclein, ischemic changes, inflammation. As you're saying, all have been associated with declining brain function. How do you think we might use these pathological findings to maybe develop better diagnostic tests or new treatments for the future?
Okay, so I forgot to answer your second question from before, which is that roughly somewhere between 50% and 2/3 of the risk of Alzheimer's disease is genetic. That's for Alzheimer's disease, not for dementia itself. These are very difficult studies to do because oftentimes when people are alive, we don't know what they have, right? And the rest is thought to be due to things that happen to you during the course of your life, right? And we're going to talk about that a little bit later, but as of using these pathologies for diagnosis, and this is really helpful, incredibly helpful, and it has really dramatically changed our ability to do research in this area, we use biomarkers. And I'm going to go back to the other slide. There we go. To talk about those colorful pictures. And so biomarkers really help us figure out what pathology is going on in the brain. Now, these are PET scans. People know what a PET scan is? Yeah, okay, good. So people developed PET molecules, so molecules that will emit these positrons that can bind to amyloid and tau. And they also can look at the pattern where the brain is degenerating by looking at how the brain uses glucose. Because glucose is what the brain needs for energy. So on my right-hand side is a glucose scan, and in an Alzheimer's brain, which is the second one here, you can see there's a decreased glucose utilization in particular parts of blue color when it's lower. And so when you see the particular pattern of decreased glucose utilization, you can have a little bit better information about what disease it might be. But even more specific, you can look at the accumulation of amyloid. So the bottom brain is an Alzheimer's brain, and this third brain over. And there's a lot of amyloid, so it's red and yellow. And then the final brain is tau. And you can see that in the same kind of regions of the brain where the decreased glucose utilization is where the tau is accumulating. And tau is a protein that's, we think it accumulates because of amyloid. That connection is one of the biggest areas of research right now that's going on even in one of the labs in my department. And what happens is that amyloid is accumulating 20% 20, 30 years before people have Alzheimer's disease, and then over time it leads to this accumulation of tau, and that's actually what causes the neuronal damage. So that's why there's this overlap. We are rapidly developing tests that can be used. Right now we have one on spinal fluid, but also blood. And so we'll, in the future, be better able to develop tests to tell you that you might have amyloid and tau pathology. And recently, several medications have shown a lot of promise in clinical trials, specifically for those people who have biomarkers positive for amyloid. So these are anti-amyloid targeted therapies that are, one is actually approved already by the FDA, but hasn't achieved full approval, which should be happening this summer. And the second one is also is under consideration with the FDA. They have very similar efficacy and safety profiles.
So, as a physician, I'm really interested in disease prevention, but if I can't prevent it, is there a way to delay it or delay the progression? Can you tell us a little bit about what you're finding about ways to delay or prevent dementia? And I'm especially concerned if, suppose you have a family member who has Alzheimer's, what should you be doing to improve or delay the onset of Alzheimer's?
Okay, well, I'm going to forget the slides. I'm just going to say that there's quite a lot of things people can do to both delay and slow the process of cognitive decline. The first is doing all the things to decrease cardiovascular, cerebrovascular risk factors, so blood pressure, cholesterol, etc. Exercise, very, very important.
How much?
Well, that's one of those things that's incredibly difficult to study, but it doesn't look like it has to be a ton, right? So regular, moderate exercise has benefit. And then social engagement and avoiding social isolation definitely has benefit, and especially in the slowing of cognitive decline once it starts. And then lastly, sleep. And sleep is not as well known, but an incredibly important thing for protecting brain health. There are now understood biological mechanisms behind why sleep is so important, and it's clear from epidemiologic studies that having either sleep apnea or insomnia that remain untreated are high risk factors for developing dementia, and treating those disorders actually has about the same effect as the anti-amyloid drugs which are coming on the market in terms of slowing cognitive decline. So, yeah, that's surprising. But we do think actually that sleep is one of the mechanisms for clearing amyloid from the brain, so it does make some sense why treating sleep disorders is so important.
So I know there are heart-healthy diets. Is there a brain-healthy diet?
Well, there's a lot of overlap. Actually, all of the diet literature that shows any benefit is from the same mostly same literature that shows that diet can help in the treatment of hypertension. So DASH diet, Mediterranean diet, those diets have shown some benefit. There's not a lot of evidence about supplements or specific dietary, eating more fish or eating more blueberries. There's always stuff in the media about one study that shows blueberries, but it's very hard to put it together into any consensus. So I think the best approach is those typical heart-healthy diets are also brain healthy.
And finally, you talked a little bit about who might benefit from some of the recently approved treatments. Could you discuss that a little bit further and maybe tell us what you see on the horizon for intriguing therapeutic targets for the future?
So right now, and we are just in the process of developing what we will hopefully will be rapid evaluation clinics for who might benefit from these medications that are coming. The studies were all done on people who had MCI or very early Alzheimer's disease. So people who are already very symptomatic, really, we don't think that there would be a lot of benefit. Because again, once you have a lot of tau and neurons are disappearing, there's really no way of bringing them back. So these are really treatments that are aimed at preventing the continuation of a pathology that has already sort of gotten started. So yes, early stage or MCI people who have biomarker, either by PET scan or cerebrospinal fluid, evidence of amyloid, are the people who will benefit from these treatments, as best as we can tell from the trials. There are some people who are not able to take these treatments. These are people who have a need to be on blood thinning medications. So because there is risk of hemorrhage, brain hemorrhage from these medications, we are unlikely to be recommending them for people who have, who have a heart valve or who absolutely have to be on a blood thinning medication. And I think, there's one other thing. There's a genetic contributor to Alzheimer's disease called ApoE4, and if you have that gene twice, you're also at an increased risk of the brain hemorrhage from these drugs, and so we're probably not going to recommend people with 2 copies of that ApoE4 gene undergo this treatment. In the future, we are really looking for treatments that have better safety profiles, that won't cause these brain hemorrhages, and there are also oral agents that are under assessment right now that may have some evidence that they would actually reduce amyloid accumulation in the brain and then not have the same safety profile. So I think that's the near future. In the far future, obviously, there's people are looking at actually treatments that are aimed at both amyloid and tau, and potentially would combinatorial treatment be better at completely arresting the disease. We really don't know that because actually the anti-amyloid drugs are reducing tau accumulation as well. So it may take a little bit more, or maybe a lot more understanding of this transition between amyloid accumulation and tau accumulation to help us figure out what's the best way of treating people, maybe even before they're symptomatic. And that's the other thing, is screening for risk is probably going to be part of your midlife evaluation, the same as getting your cholesterol and blood pressure checked today. And in the future, we hope that we can, find these things before they start, just like your, colon cancer screening, and prevent them from even getting started.
So what test is the best one for screening?
Well, right now we really don't have that, but if you are, meaning pre-symptomatic, if you are interested in knowing whether or not you have this ApoE4 gene, there are ways you can do that. In the future, when these blood tests for amyloid come out, they are abnormal, like 20 years before people develop symptoms. So as they become more and more sensitive, and we understand more and more the norms for the blood tests, I think those blood tests will start to become screening tests. There are a whole bunch of other things that are more researchy, looking at neurodegeneration in the eye, combinatorial MRI. It's very quantitative with like artificial intelligence, and eye evaluations in the same kind of way may have some promise, but they're probably going to be too expensive for a regular screening test. So I think most of us are mostly hopeful for these blood tests.
Thank you. So, Dr. Meltzer-Brody, we've talked a little bit about our aging brains. Can you describe a little bit about what may be going on with our mood and our mental health as we age? Is there a difference between men and women, and do declining hormones have any impact?
Absolutely. So it's a pleasure to be here, and congratulations to all of you on your 50th reunion for those celebrating. So I'm going to skip ahead here.
I think go back.
Oh, go back.
Yep, sorry, put them on
Okay. So as the chair of psychiatry, we are faced with confronting the current mental health crisis in our country, which is massive. And the prevalence of depression and anxiety has increased 3 to 4 times over the last few years, over the course of the pandemic in particular. And there's lots of reasons why that may be the case, including the social isolation, the impact of the social media, people living in their own sort of echo chambers with lots of negative sort of socio-political discord, and lack of connection and community. And in fact, the Surgeon General came out last week with a report on loneliness and isolation being one of the greatest public health threats we face. So with that as a context, here in the Department of Psychiatry, we're a very large clinical research and training department. We take care of people across the entire life cycle. We take care of kids and adolescents, and we take care of elderly adults. And I'm very fortunate to be able to partner with Gwenn Garden around geriatric psychiatry and the interface between depression, dementia, and everything in between. So as we age, there are many changes that happen to our brain, and mental health is ultimately a brain disease. There's certainly the connection between our genes and our environment and our life events, the coping skills we developed or didn't, and all the factors that can mitigate whether someone does well or does not, which is often whether you have people in your life that help support you, whether you feel connected, whether you have a community, whether you still stay engaged. So here's a slide that talks about brain changes over our life, and I can't do this and sit down, so I'm going to have to stand up. The eyes in the back of my head aren't working well today, when you're very talented. Okay, so if you see it over here in the this side, that's a 7-year-old brain. That's 15, that's adolescent. 25 is here, 35, 55, 75. And you see changes that happen in the white matter, as well as the more limbic structures of the brain, the amygdala, which has an enormous amount to do with how our emotions are processed. It's one of the oldest parts of our brain in humans over time. And people will often talk about your amygdala or your limbic system as being your most sort of primitive emotional self. But you see that 7-year-old brains look completely different than a 75-year-old. You also see that by age 25, the reason that you're allowed to rent a car at 25 by the actuarial data is that you have a myelinated brain, more or less, which is supposed to help with impulsivity. So what makes a 15-year-old more impulsive? By 25, someone decided that you're less likely to wreck your rental car. For no other good reason. I mean, you can, go to the military and be given an assault weapon, but you can't rent a car until you're 25. So what we see is over time, there are many, many differences that happen, and that's part of normal aging. So what Dr. Garden showed you is what happens when you see abnormalities in the brain. I'm a reproductive psychiatrist, so take care of women across the life cycle, but I certainly also take care of men as well. In women, you have the hormonal changes over the lifespan from the onset of menarche as an adolescent through the perinatal period through the menopause. Women have changing levels of hormones, and at midlife, which the average age of menopause, which is defined as 1 year without a period in this country, is 51, 52. And you start seeing the difference between menopause and depression. You see cognitive shifts, sleep disturbances, sexual disturbances, energy changes, weight changes. All of that occurs in the midlife. We see a peak in depression that goes up. And then often on the other side of the menopause, transition may go down. But it's really important that people pay attention to that and get intervention at that time if they're struggling, so it doesn't persist into more difficulties as people continue to age. In men, you don't have the same sort of menopausal transition, but you have decreasing levels of testosterone over time that can also cause changes in mood, anxiety, libido, sexual functioning. As we age, the changes in the roles we have in our life. markedly changed? Do we feel valued in our role as a parent, as a member of the community, in our work roles? For some people, retirement is a crisis point, going from feeling valuable in your contributions at work to what am I going to do when I no longer have that role? For older adults, depression can look different, and we can define what's an older adult. I'll be 55 in July, and I keep defining older, it keeps getting pushed out. My early 20-year-old children think I'm ancient at this point, but we know that older adults have an increased risk for depression, and some of that is because of other health issues that occur, changes in supports, and then the brain changes that Dr. Garden described, the huge overlap between dementia and other mental health concerns, which again are due to the fact that whether you have depression, anxiety, whether you have a psychotic disorder, ultimately it has to do with disruptions in the brain. We know that 80% of older adults have at least one chronic health condition, whether that's hypertension, diabetes, arthritis, inflammation, heart disease, and that increases risk of depression and anxiety. Inflammation, which is very common across so many different disorders, increases risk of depression, and most of this is biologically mediated. We also know that older adults are often undiagnosed, misdiagnosed, and undertreated. People can just brush off things as not being important, or maybe you're just a little lonely, or maybe you're not getting out as much. And we have to see depression as something that can be treated. It makes a massive difference. So if people are depressed, they're not sleeping well, they're not taking care of themselves, they're not exercising, and you just heard Dr. Garden say, all of those things are critical for good brain health. So the correlation between people that start being depressed, and then because they're depressed, not engaging in things that lead to a healthier life, can then increase risk for dementia. So taking care of your physical health and your mental health is critical. We have to foster resilience and mental health, and this is a slide that talks about healthy aging, and if you see the bottom arrow in brown over the life course, healthy aging is about what is our social and physical environment, and what's the sort of yin and yang between things that are restorative on the left here and things that are cause deterioration on the right. That's health behaviors, our biologic functions, and our psychosocial functions. And there's always the contribution of stress, how that impacts our psychological well-being, and how that impacts our social well-being. And for older adults over the pandemic, the loneliness and isolation is such a terrible risk factor for both dementia and depression. We need each other, and that's why being connected and staying involved in things that keep your body active, your brain active, and your social community active is so important. So I wanted to leave you here with a few pearls. It's so important to maintain a daily routine with a daily wake cycle and sleep cycle. Getting up at a certain time, going to bed at a certain time, putting structure in your day. Even if you're fortunate to be retired and not encumbered by a certain time you're supposed to show up at the office, but having structure really helps with sleep-wake cycle, which really helps with functioning. Starting your day in a positive way, yoga, meditation, mindfulness, a good cup of coffee, whatever you do, but starting it in a way that feels positive. Incorporating exercise at least 15 to 20 minutes a day. And again, it really just makes such a difference, not only in whether you can fit into your pants, but in terms of how the rest of your body feels and how your brain functions. Staying connected to people in your life through whatever communities you have, you've got to stay connected to stay well. And for older adults, starting new projects and things that inspire you. These things can change over the course of our lives, but it's never too late to say, I'm interested in this particular issue, or I'm interested in taking up this hobby and doing things that get you excited and inspire you. And lastly, to say, if you're struggling to reach out for help, there's been such stigma about mental health, and our younger generations are more open about seeking help. In fact, they tweet all their mental health concerns and put it all on social media, much to the chagrin of older people. But I think that for older adults, really saying, I'm not feeling my best and I'm much more sad, or I don't want to see people anymore, I've lost interest or pleasure in things, or I'm very anxious, and getting help for that can make a tremendous difference.
So just a couple questions. I know when people have cognitive impairment or dementia, it's so often accompanied by mood changes. They're more depressed, they're more agitated, they're more anxiety or behavioral changes. What's causing that?
Well, you end up with disruption in the brain, and so that causes disruption in the transmission of the biochemicals, neurotransmitters, that causes disruption in neural circuits. It causes disruption in perception. It causes disruption in sort of emotional lability. So it really is a brain disease. And our understanding of the brain is so much less than certain other organs. But neurology and psychiatry have the same board, the American Board of Neurology and Psychiatry, and it's all brain health. Our understanding of it is less obvious than our understanding of something like the heart, which in comparison is quite simplistic. It's a pump. And the brain is enormously complex, but everything is connected.
So you talked about the importance of getting treatment if there's a mental health issue. Are there differences in how you would treat a younger individual versus an older individual?
In general, the gold standard for treatments, whether psychotherapy, talk therapy, or medication therapy, are the same. With medication treatment, you're going to adjust doses and pay close attention to other co-occurring medical illnesses. You're paying attention to how a drug is metabolized as people age. You're often having to use lower doses or adjust for those things. There's some medications that are less favorable in older people. But psychotherapy and counseling can be enormously effective in any age group. Paying attention to all the environmental and social factors in someone's life, it's never too late to work on those. So I would say treatment can be so effective.
So I just want to also add that in many of the neurodegenerative diseases of aging, sometimes the first presentation is actually a serious mental illness episode, and sometimes it happens before other cardinal symptoms. And one of the things that has been noted is that when people are refractory to usual therapy, that can be a sign that that the mental illness episode may be a harbinger of another disease. So, so it's just something to think about both from the standpoint of, well, why? And we do think that this inflammation in the brain associated with these other pathologies is probably also contributing to mood disorders. Hopefully somebody will figure out how to treat these treatment-resistant episodes, thinking about that underlying biology.
And that's why we are very excited to partner. We are growing our geriatric psychiatry program with people that are able to be specialty trained. We're starting a geriatric psychiatry fellowship, of which there's far too few in the country, with people that are specialized in psychiatry, collaborate with neurology around this interface. So treating depression in older people is so important, and as Dr. Garden said, if people are not responding, then you really have to say what else is going on and think about other things. But it is a really important area that has been neglected and needs to have much more attention.
Can you tell us a little bit about what you see as maybe new or emerging treatments on the horizon for depression or anxiety?
Well, there's a lot of excitement and a lot of development in new forms of antidepressants, new forms of non-pharmacologic treatment for depression. So in the world of neuromodulation, you may have heard of RTMS, which is repetitive transcranial magnetic stimulation, which is this little gizmos that stimulate parts of the brain that can lead to depression treatment. There's a whole world that's looking at non-invasive forms. So if you think of something like electroconvulsive shock therapy, ECT, which remains extremely effective. People often think of One Flew Over the Cuckoo's Nest with great horror, but it's the best way we know is you generate a seizure which causes a flood of neurotransmitters, and for reasons that we're still not entirely clear, treats depression. This is a way of causing changes in neurotransmitters and how the brain is working without the invasiveness of something like ECT. So RTMS is very exciting. There's a lot of work looking at ketamine and intranasal ketamine. which we do here, interventional psychiatry techniques. I've been involved in the drug development around the first treatment for postpartum depression, and now an oral drug likely to be FDA approved later this year is zuranolone, which is a positive allosteric modulator of GABA, which will be for both depression in general, as well as postpartum depression. That will be a new kid on the block for treating depression outside of traditional antidepressants like the SSRIs. And then there's a number of other things on the horizon. You may have heard of psilocybin, which is getting a lot of attention, and other pharmacologic agents. So there's a lot of interest in this area and a huge need for novel treatments, including novel ways of delivering psychotherapy and new forms of brief interventions that are very helpful.
Thank you. So finally, many of us have become doting grandparents, and it seems that today's youth don't face the challenges, face the challenges that we didn't face many years ago. Can you talk a little bit about how or what we could be doing to safeguard the health of our next generation?
So it's one of the things that keeps me up at night is what we're going to do about the child and adolescent mental health crisis, which is devastating. Suicide's now one of the greatest causes of death for teens. It's very complicated why. If you talk with them, they will talk about the fact that they feel they're living increasingly in a world where they don't see a lot of hope. I think that the social, political discord, the polarization, they're worried about climate change, they're worried about how they're going to make a living, they're worried about any number of things, and then living their lives in sort of the social media world is extremely difficult. So when we look at what's dramatically changed over the last 20 years and the really negative impact on their health, what's the one thing that's dramatically different that wasn't there 20 years ago? It's like some of these things, right? So how we figure out how we're going to help them take control of that. The problem is that many people believe, and there's experts that study social media and the impact on teens, is that the parents of these teens often didn't grow up with these things. And so the parental ability to understand the influence, their experience at that age is dramatically different from where the teens are. We as a society are going to have to figure out what are the guardrails and how we have literacy around this, how we, in many ways, I think the tail is wagging the dog, particularly for our kids, and how we're going to figure out new paths forward around that. I think it's unlikely we're just going to like put them in the garbage and move on, but we have to address that head on. And we're going to have mental health literacy and really talking about mental health and providing skills for our kids in ways that they are not getting now. What's going to be the responsibility of schools, faith-based communities, other things that they do not have the skills to cope well that they need, as well as scaling up more formal mental health treatment. But on the spectrum from prevention to treatment, we need a lot on the prevention side. That, I feel very grateful, is a big focus of what we're doing here. We have a new child and adolescent mood and anxiety disorders program. We are partnering UNC Health with the state to open a new child and adolescent psychiatric hospital in a few months. And so really trying to do our part to address this crisis, but it definitely is complicated and will take all of us working together.
Thank you. Now let's turn our attention to preparing ourselves for the next pandemic, as hard as that is for me to think about. So, Mr. Rosen, would you talk briefly about COVID and maybe some of the lessons you think we should have learned from the pandemic?
I just hope I can stick to my thoughts here because I just learned so much from the prior two panelists. And I was also amused to see that there was such a gap between the 7-year-old brain and the 15-year-old brain as the father of an 11-year-old boy. I'm pretty sure if we put the image of the 11-year-old brain up there, it would just be an empty cavity. Kidding aside, I mean, if we just pause and if I asked you if there was something you could do to prevent 7 million deaths, to prevent the developmental delay of young children, and to develop $14 trillion of economic damage on this planet, you would all just pause and say, of course I would do something about that. But here we are in this cycle of panic and neglect that we go through in talking about pandemics. And we now have pandemic fatigue. We want to put COVID-19 behind us. But pandemics are inevitable. I mean, they are like earthquakes, hurricanes, mudslides, floods, you name it. They are a natural disaster of sorts. And we put a lot of effort and energy into building sturdier homes, into building built communities that can withstand these tragic events in the environment. But when it comes to pandemic preparedness, we are embarrassingly unprepared. And so the number one lesson from COVID so far about how to prepare for a pandemic, the answer is do anything. Just prepare, start now. Another challenge with preparing for pandemics is that the medications that we need, and this is what READDI does, and we'll talk about that in a minute, the medications that are needed to intervene in a pandemic take 7 to 10 or more years to develop. You cannot wait until the disease is identified or the viral outbreak occurs or the spillover event from an animal is identified and the sequence of that virus is known to start developing those drugs. That's like trying to install a sprinkler system in a building when it's on fire. So you have to start sooner rather than later, and the answer is start now. The United States and the World Health Organization, WHO, have just declared the end to the COVID-19 pandemic, but 1,000 people a week in the United States alone are still dying of SARS-CoV-2 infection and the COVID-19 disease. And this is not the time to stand down, it's the time to stand up against the next pandemic. The other thing we need to do and get in our minds is that the next pandemic might not be a coronavirus. We don't know from which virus family it's going to come, but we do know the set of virus families from which it's most likely to come. And there are conserved features of those viruses that we can target with medications. And so just as we build our military to prepare ourselves from threats domestically and internationally, and we have Army, Navy, Air Force, Marines, Coast Guards, we have special forces that we deploy, we put really expensive planes in the air at $1 billion a pop. We need to prepare ourselves with public health measures, with therapeutics, and with vaccines that are prophylactic, preventive. Sorry, go ahead. So it's taking a broad approach to pandemic preparedness that is probably the biggest lesson, the lesson that we learned, and I'm hesitant to say that because it's things that we already knew and there were people standing on rooftops screaming it, but everybody was ignoring it. So we need to behave differently next time and take our preparedness more seriously.
So I'm so excited to know about the formation of READDI. Can you tell us a little bit about what that is and who the partners are in that undertaking?
Sure. I mean, the inception of READDI is sort of like the setup to a joke. You know, 3 virologists walk into a bar. It was Ralph Barrett, Matt Morman, and Mark Heisey, who are 3 virologists here at the University of North Carolina at Chapel Hill, who before COVID-19, before SARS-CoV-2 was identified, were having a beer after work on a Friday one day and said, you know, guys, we're probably better situated on this campus than almost anywhere in the world to predict what the next pandemic is going to be and to do something about it. And they formed READDI. READDI, the inception of READDI predates COVID. And so now people might say, well, why the hell didn't you do anything about it then? Well, they did, and not enough people paid attention. And so READDI then was transformed during COVID into what it is today, which is a very well-funded research enterprise here on this campus, but also, it is a collaboration among the School of Medicine, Virology, the School of Public Health in its epidemiology capabilities, and something called the Structural Genomics Consortium on campus. READDI also has collaborators all around the planet. These are academic collaborators, industry collaborators, and those from government who work in drug development. And READDI was created to discover and develop small molecule broad spectrum antiviral drugs. Small molecule means pills. They can be, these are chemicals that can be pressed into pills, taken orally with a drink of water, no matter where you are in the world. And the ability to get those therapeutics, to get those pills to everyone on the planet when they need them, where they need them, is the way that you can stem the uncontrolled outbreak of a pandemic. The broad spectrum piece is what I alluded to previously about the virus families from which the next pandemic is most likely to come. READDI is creating broad spectrum therapeutics. This is a single drug that can hit every virus within a virus family. And if you can do that, then it doesn't matter what the exact virus is. So SARS-CoV-2 didn't exist before COVID. It was called the novel coronavirus when we all first heard about it. But if we had broad spectrum coronavirus therapeutics, then as soon as the novel virus came out of the coronavirus family, you can deploy this drug and it will be safe and effective at the time that virus emerges.
So this sounds like a really great vision, but tell us a little bit how you translate this vision into reality.
Yeah, well, it's about the medicines. It's about actually creating those pills. So we have at READDI, and I'll tell you a little story. I spoke at an event about a month ago that was put on by a group called the Intrepid Alliance. And the Intrepid Alliance is marketing itself as a group that's helping with pandemic preparedness. A bunch of very, very smart people who are highly motivated against the same mission that we are at READDI. The first speaker in the group was somebody that represented the G7 Pandemic Preparedness Secretariat. The second speaker was somebody from the Office of Science and Technology Policy at the White House in the executive branch. And both of them said, wouldn't it be great if somebody did a landscaping exercise and created a database that showed us all of the antiviral drugs that people have tried to develop, those that are in development now, what is their status, their stage of development, their mechanism of action, their biological target, etc. Well, I was the third speaker, and I sat up there and I said, I was so happy to hear how wonderful it would be if we had such a tool. READDI has already created it. And the answer is that we are doing the work on this campus and in this community right now that is getting ahead of those questions and actually doing the work. So we've now taken that database and it shows us what's worked, what hasn't worked, and where are the gaps. And we now have assembled a prospective pipeline within READDI of over 20 small molecule drugs that we can take through a development pipeline. So the answer is, how do you do it? Well, drug development is not a mystery. I mean, the steps are pretty well known. But you've got to have the chemical matter that you're going to take into those early preclinical stages of development, fund them through that preclinical stage, get to candidate drugs, get those candidate drugs into the relevant preclinical models, and then get them into human beings to make sure they're safe. And where viruses exist that we can test to see if some of those drugs are efficacious. And ultimately, in places where indications do exist, we can actually test whether those drugs are effective.
So I understand you'll have these small molecules on the shelf waiting to be deployed. How do you actually identify and deploy them and get them into development? Because I know that drug development is a very expensive undertaking.
Yeah, I mean, I might take that in reverse order. I mean, the best thing we can do right now is to predict what are the virus families from which the next pandemic is most likely to come, and create these broad-spectrum small molecule antiviral drugs. Then we form collaborations with pharmaceutical companies and governments to stockpile these drugs and strategically locate them all over the world. Another thing that another group is working on, not READDI, but another group, is to have continuous manufacturing capability in geographies around the world, so that when you need to actually truly scale up to the hundreds of millions of doses that are needed, or even billions of doses that are needed, that you can strategically do that where those doses are needed. So you cut down on the afterthought of supply chain issues, distribution, and getting those pills into the hands of people who actually need them.
So I know that working with viruses and developing antivirals generates some safety concerns. Thinking about UNC, how do we control biohazard materials here?
So, obviously you all know the medical profession, you deal with biohazardous materials all the time, and there are ways to handle and dispose of those. We have on this campus what is called a BSL-3 facility. So BSL-3 is handling dangerous viruses, but not the absolute most dangerous ones. Those go to BSL-4 facilities elsewhere. We do not handle those on this campus. But BSL-3 facilities have appropriate ventilation, negative pressure environments, have the filtering where necessary, and containment protocols in place that are federally mandated and regulated. We have exceptionally well-trained people, especially here, who know how to handle these facilities and deal with the eventuality of handling a virus that we haven't seen before. So it's appropriate to be concerned. I mean, again, it's like being concerned about fire safety, but if you have the right protocols in place, we do not worry on a daily basis about anything like that happening on this campus. The environments are extremely well controlled, secured, isolated. You cannot even enter them without the appropriate credentials.
So my last question is, I've been reading a lot about the avian flu, and there's even a proposal, understanding, to vaccinate millions of poultry. In California, I've been reading that condors and eagles are dying. How concerned should we be about zoonotic and non-human viruses?
Well, the answer is very concerned. I mean, it's spillover events from animals that lead to these pandemic events. I mean, it is much more likely that the next deadly virus is going to mutate within an animal that lives in close proximity to human beings, and there will be a spillover event from this animal into a human population, and then this virus will have to have mutated to a point where human-to-human transmission is possible, which is what leads ultimately to a pandemic. So the answer is, how concerned should we be about zoonotic transfer and these things that we call spillover events? The answer is we should be very concerned. That's part of pandemic preparedness. And this is part of the epidemiology exercise and the virology exercise, to go to communities that are adjacent to where these animal populations exist and identify what's happening virologically in those communities. Are new viruses showing up in the people who live in proximity to these animal communities that have the species of animals that are most concerning in crossover events? As far as the avian viruses go, vaccinating poultry is a very, very, very long-standing practice. I mean, there's an incredibly innovative company that was formed here in the Triangle that vaccinates vaccinates chickens before they've hatched. So animal vaccination is pretty tried and true, and it's well practiced. It's a matter of how quickly can we identify the viruses of concern, formulate them into a vaccine, and then be able to deliver them in volume into the chickens before they even hatch.
Thank you. So I realize we've covered a lot of ground this morning, but we purposely allowed time for questions, either among the panelists or among the audience. So what's on your mind? Yes, and we have one mic, so either speak loudly or... Okay.
I don't project well without this, but I was interested in the families of organisms. Would that be the same thing, treating the whole family as a universal vaccine? I had read that there was one research project that just was finished enough to start clinical trials when coronavirus broke out, and so it was off the table at that point with Operation Warp Speed. But would that be the same thing? Would be the universal virus, universal vaccines?
So even a quote-unquote universal vaccine is probably going to be limited to a family. Working across families, different families of viruses are quite different structurally and biochemically. And it is really hard to find a therapeutic or a vaccine that will mount a sufficient immune response to enough across virus families. And the trade-off there is side effects. So, you can come up with something that kills every virus we know of. It's called bleach. But we wouldn't give it as a therapeutic. And to administer a vaccine, that would mount a sufficient immune response that it would be effective against all viruses is that immune response would just as likely kill us.
Well, some people did do it.
Some people did advocatively, yeah. That was the comedy value right there. Yeah.
Right. That was for the flu specific. The flu virus.
Oh, universal flu vaccine.
Yeah.
Yes. So that, and again, now staying within a family, I think technically that's a great aspiration. We should be going for that.
And I'm sorry to tag on another, but would the mRNA technology that we've jumped to work for corona? Because there was talk about universal
mRNA technologies are fantastic. I mean, they are transforming medicine, not just in infectious disease, but in oncology and other indications. Absolutely. Yeah.
Would small molecule treatments be less likely or more likely, or more, I guess, subject to mutations of the virus to evade?
Great question. The answer is they are less likely to fail as a result of mutation events. They're less likely to spur mutations or cause mutations, but they are not. They're not immune to them. Antibody therapeutics are the most likely to fail as a result of mutation because they're so highly specific. It also makes them really safe and very effective against the thing you're targeting. But there is not a single monoclonal antibody that survived the development process through COVID. Every single one of them has failed due to lack of efficacy as a result of the virus mutating away from what they were targeting. Vaccines are more durable, and just like the flu, we can tailor a vaccine on an annual basis to keep up with virus mutation. It's an epidemiological exercise and a statistical exercise to make those predictions about what you're going to be targeted against. But the best approach with small molecules is actually to come up with polypharmacy, which is to say, develop therapeutics that hit the virus itself, which we call direct-acting antivirals, and develop those in conjunction with things that hit host targets. So how do you protect cells from getting infected by the virus directly? So in the host, meaning in the person. And if you can prepare defenses within the person to prevent virus from penetrating those cells or prevent the virus from replicating within the cell or transmitting out of the cell, and knock down the capability of the virus itself to infect, that dual approach is the best approach. And that's what we're working on at READDI. We're working on both direct-acting antivirals and what we call host-targeted therapeutics.
Oftentimes, the receptor is a molecule that's already there for a function. Do you endanger the person by taking that function away?
It's what makes those targeted therapeutics harder to develop than direct-acting antivirals. But the answer is, it depends. Yeah, that's on the
Next
target.
question. I'm a retired teacher. Nobody ever accused me of being too quiet. I have two questions, actually, for the ladies. What effect or impact would hormone replacement therapy have, particularly that which was started in the 40s? And the second question is, and this is huge, but it's in my family, what do you say to anti-vaxxers?
Okay, so it's a really complicated question, hormone replacement therapy in terms of dementia prevention. There was just recently an article in the New England Journal about this topic, and I think it's still, even with that article, controversial. And it's also difficult because hormone replacement therapy has its risks, right? Cardiovascular risk, if you have breast cancer risk. But there does appear to be a window and it's not clear that it's, the earlier part may not be important, but there seems to be a window some number of years after menopause, but before one gets too far down the road, that hormone replacement does appear to have some dementia prevention. I think more research is needed for sure, and also to try to understand why. We really, there is an increased prevalence of dementia in women over men, and it's not completely well understood why there is that difference in prevalence.
We certainly see women for whom hormone replacement makes a massive difference in mood and functioning, including cognitive functioning at midlife. So we will see people in consultation who will say, I'm going through the menopause transition and I'm an attorney and I can't think straight anymore. And so whether or not to do that always has to be a very thoughtful conversation with the patient and the doctors looking at risk and functioning and seeing what's the path forward. But for some people it's really important for their functioning overall. It makes a big difference. So it is like everything, it always depends, but requires a thoughtful conversation. And I'll pass this on what to do with the anti-vaxxers. What to do with the anti-vaxxers?
I just want to say that you didn't mention this, I don't think, but Ralph Barrett's lab on campus
Has been under siege, and there's, armed security to protect it from terrorists. So I worry much less than from anything escaping, and more about the terrorist attack on campus, which I don't think is, he's had horrible death threats. I don't think that's an overstatement of both his dedication and the danger that people trying to work in this area face.
So I'm a graduate of the School of Public Health here, and I very strongly believe in our responsibility to take care of the public's health, beliefs aside. There's also 30% of the people on the planet who don't have access to vaccine and still are unvaccinated from COVID-19. So we are developing therapeutics as part of an armamentarium in what we deliver as healthcare and our responsibility as public health people. Therapeutics are not an alternative to vaccine, and vaccines are important to stem pandemics. But in our responsibility at READDI, we want to get those medicines to everybody who needs them, where they need them, when they need them. And we don't take belief into consideration organizationally. We can have a side conversation about what I believe personally, and it will align, I'm sure, with what you're implying with your question. But it doesn't factor in on a daily basis to how we develop drugs within our pipeline at READDI and how we deal with our responsibility to take care of the public.
Mr. President, I have two questions. First, one for you. What does READDI stand for? And for Dr. Brody, in the picture with the slide of the brains. I noticed in the 55-year-old, there was a different color, which I think indicated instability. Is that due to menopause, maybe?
It's the midlife changes, but yeah, you see multiple changes with decreasing hormones over time and the change.
Can I answer? Let me-
Yeah, go ahead.
The acronym is Rapidly Emerging Antiviral Drug Development Initiative.
Hopefully a quick question for the gentleman. Should READDI be on target and have developed the right broad spectrum vaccine, do you think that the regulatory agencies will be poised to act quickly? In other words, will you have gone through testing and so forth so that it's sort of a plug-and-play situation?
It's a fantastic question. So we're developing therapeutics. We are specifically not working in vaccines. So READDI is strictly small molecule therapeutics, just to be clear for everybody. The regulatory question is a great one. The answer is it depends. You remember we're working across virus families. Some of those virus families have diseases within them where we could test therapeutics. So I'll give a quick example, which is alpha virus. So there is a global health condition called chikungunya virus, or CHIKV. It has nothing to do with chickens, spelled very differently. But chikungunya virus is an alpha virus. There is a large outbreak in Central and South America right now of CHIKV. If we had a small molecule broad spectrum alpha virus compound that we were developing for pandemic preparedness use, and there are equinoencephalitic conditions that are caused by other alpha viruses that have the potential to become pandemics and are really nasty, we could pursue an indication for that alpha virus drug for CHIKV specifically and take it through an established regulatory process, because the population exists in which to test that drug. In other virus families, there is no large population of infected individuals today. So we're talking about developing a drug for disease X. That stretches the ability of the regulatory authorities right now, because they are not accustomed to having people say, I want to get a drug approved for a disease that does not yet exist. And so how are you going to test it? How are you going to demonstrate that it works? For those virus families where that's the case, we will only be able to take that drug as far as what we call phase 2 ready. So take it through phase 1, test it in healthy human volunteers, establish its safety, and then we have to park it. And then when the outbreak occurs, and there is a population of patients, we would agree a priori with the regulatory bodies of what a phase 2 trial would look like that could lead to an emergency use authorization like we saw with the vaccines and COVID.
How many virus families are there?
There's a lot, but we are most concerned with about 7 of them. There's about 7 from which the next really deadly nasty virus is going to come. Yeah.
Question for you, Mr. President. Even since the pandemic, we've seen an increased level of tension on a global level, both in Asia, obviously in Europe with the war in Ukraine, et cetera. As you try and plan for the next pandemic, what efforts can READDI and the private universities around the world be doing to sort of circumvent this level of tension that we have on the global level right now? Easy question.
I don't know if I'm smart enough to answer that question. That would probably take representation from many of the schools on this campus to formulate a clever answer to that. I'm not smart enough to answer it, but I'm maybe stupid enough to try. I think we need to, READDI just needs to rise above it. I mean, we have a very specific focused mission to stem the next catastrophic event that has already cost over 7 million lives, $14 trillion in economic damage, years of lost learning and development for our children, isolation for our elderly, that ties in very closely to what the two esteemed people on this panel talked about. And so we need to be very clear in our communication to governing and regulatory bodies. We need to be very clear in our communication to the pharmaceutical industry and to say that the resources that it would take to develop the arsenal of drugs that we're talking about is somewhere in the neighborhood of $1 billion. It's not a lot of money in the grand scheme. And if somebody said, would you invest $1 billion to prevent the next COVID-19? The answer is, of course we would. You'd have to be an idiot not to do that. Well, there's some idiots in Washington right now. Convince them not to. I think I might just stop there.
Next question.
I had several questions, and you've already answered one of them.
Hopefully for our other speakers.
In our normal day-to-day lives, we drink a lot of coffee, a lot of tea, Cokes and stuff. What are the effects of sugar and caffeine on the brain, and the amounts that you drink during the day?
Okay, so well, let me start with caffeine. So there's not a lot of great epidemiologic evidence on caffeine because it's like everything lifestyle. These are really difficult to study. And I hope you can all understand that it's incredibly difficult to get people to come in to a study and say, well, I will drink exactly 1 cup of coffee that has a very specific amount of caffeine. Like, I can't make my own coffee. I can't buy it at Starbucks. I can't, So it's all sort of, well, how much caffeine did you drink? Well, I think I drank 2 cups a day about on average. So it's tough, right? It's tough to answer these questions. But I will say, just from a practitioner's standpoint, like and a life standpoint, the biggest concern about caffeine is sleep, right? We talked about how important sleep is, and what caffeine does is it often, and especially more as we get older, prevents people from sleeping and sleeping well. So, to the extent that we as a society use caffeine purposely to sleep less. Okay. Sorry. Sorry. Using caffeine to wake up in the morning, again, if you don't have strong epidemiologic evidence, I cannot tell you, and certainly not have stopped using it myself, is one thing, right? But using it to stay awake when one feels the need to sleep after, a long day of work, or even after a high carbohydrate meal, that may not be such a good idea. So I don't know if that's answering your question, but I think that's the way to think about caffeine in your personal life. Sugar is another really interesting question for which we still, I think, don't have enough data. But we talked about heart-healthy diets and Mediterranean diets, and it is really kind of an experiment of society, this use of refined sugar. It's definitely not part of any evolutionary diet, and it certainly is contributed to a lot of metabolic disorders, and that includes, obviously diabetes, but other metabolic disorders that influence even, the hormones at menopause, the hormones pre-menopause, and if one were to say, well, is sugar itself a problem? Not, it's not a problem. It's like everything in moderation. If you don't develop a metabolic disorder, but if it's like a prevalent part of your diet and you are tending toward diabetes, there are changes in the brain that we track, and there are definitely changes that accelerate with aging that seem to contribute to cognitive decline. It may not exactly be Alzheimer's disease, but the relationship between the molecules that control sugar and cause it to be in a reasonable concentration in your blood, they seem to have an age-dependent capacity, which is also partly why diabetes is more prevalent as we age. So that that link between obesity and diabetes, it gets you have to be more obese to get diabetes at a young age, and then as you get older, you can develop diabetes even without having any obesity.
So let me interject too with alcohol. As long as we're talking about caffeine, sugar, we had keg parties 50 years ago, but I'm assuming alcohol's not so good for the aging brain.
Don't answer that question.
So I'm going to only say this. So we, there actually is, data, and again, just like we're talking about caffeine, it's very difficult to get at these kind of things with studies, but there is data to suggest that, minimal, moderate drinking is not dangerous and potentially not, and potentially even maybe beneficial for certain things. But it's very minimal, right? Now, regular drinking, even in the absence of alcohol use disorder, is potentially a risk. So, yes, you have to kind of really understand that it's probably not dangerous to consume a small amount of alcohol. Maybe there's some benefit from red wine. I don't know if there's enough to say that you should drink it every day. But there's definite risk associated with regular moderate drinking and certainly with alcoholism.
But one thing to add is that having a life filled with joy is important. And most of the studies, if you look in mass, living this sort of restricted monastic life in the hope that and then you die of some horrible cancer because you were just had bad luck. And meanwhile, you were suffering eating 2 carrots, no coffee, and no sugar and alcohol, which just seems like a bad bet. But I think if you have alcohol in moderation, which is defined as 1 drink a day for women, 2 drinks technically for men. Most of the studies, I mean, no one wants to talk to me in the morning before I have a cup of coffee, and for many people, 1 cup of coffee in the morning, the benefits of whatever antioxidants you get is going to far outweigh any negative effects. Getting together for a meal that is healthy, and if you have dessert and you have a glass of wine and you have community, I think is going to win the day every day on all of these things. So again, it's just moderation, but also finding joy is so important.
One more question.
Yeah, I should have just, so regular moderate drinking, what I was saying, that's more than 2 drinks a day for men, more than 1 drink a day for women.
I have 2 questions. I think the first is for Dr. Garden, the second is for Dr. Brody. So the first question, you have emphasized the importance of recognizing cognitive mild impairment. Is there a recommended diagnostic protocol for folks with mild cognitive impairment? I know you're not going to recommend PET scans for everybody, but the second question is, are there any psychotropic meds which are effective with severe dementia?
Okay, so we have started a program, and it's joint neurology, psychiatry, and geriatrics called the Aging Brain Clinic. And in the Aging Brain Clinic, if you have early cognitive change, even if you're just concerned about it and you don't think that you have it, but maybe somebody else does, you can come for an evaluation, and they will evaluate your cognition. they will evaluate your lifestyle, and they will offer both genetic and biomarker testing using spinal fluid. So we might send everyone for a PET scan who wanted a PET scan just because we'd love to collect the information for research. But Medicare currently does not pay for PET scans, and I don't know that that's going to change in the near future. And so since we actually think that we get almost as good information out of the cerebrospinal fluid, we actually offer people assessment in that way today. So the blood tests are not approved at this point. We think they're coming within the next few years. But even today, you can come to our aging brain clinic and get these assessments done. Having a spinal tap is really not a very dramatic procedure. It sounds bad, but it's really very well tolerated, and for people who really want to know, sometimes they get very good information and can help them to make the lifestyle adjustments that otherwise might have been difficult to convince them to do. And I was, especially in treating sleep disorders, many people live with sleep apnea or insomnia and don't do too much about it, or other than maybe drink a lot of coffee. And so that's, again, one of the reasons that I kind of caution people against drinking a lot of coffee is because it's really covering up a sleep disorder that needs treatment. So psychotropic medications for dementia, I actually don't know.
Well, one of the things we always try and figure out is the differential between depression or dementia for people who have early cognitive changes. And you can often treat depression and see the cognitive issues resolve, in which case it's either an early hallmark of what will become dementia or it was depression that's treated. But outside of using antidepressants to address that issue, then you'd be talking about the anti-Alzheimer's or other anti-dementia drugs.
I think we're going to do one really quick answer.
This is probably not quick, but you can make it quick. So Dr. Garden, some people I hear will speak about Parkinson's as a muscle disease or a motor function disease. Could you speak about it as a neurological disease in just any of the ways that you so helpfully talked about dementia?
So Parkinson's is a neurodegenerative disease that in most people, the first thing they notice is tremor, but it can be presenting in a wide variety of different ways. So, as we were talking about, sometimes the first sign of Parkinson's disease is treatment refractory depression. But when we look back at people who eventually develop tremor and have a diagnosis of Parkinson's disease, we kind of find all kinds of symptoms that predate that tremor, including loss of smell, chronic constipation, and changes in the way people think, where they think clearly, but they think slowly. Now, Parkinson's disease can be associated with its own dementia at the end stages, typically. And then there is this entity that is called Lewy body dementia, which isn't exactly Parkinson's disease, but it's caused by accumulation of the same protein that we see accumulating in parts of the brain in Parkinson's disease. And in Lewy body dementia, instead of being confined to the back parts of the brain, this abnormal protein spreads throughout the rest of the brain. So patients do sometimes have symptoms of Parkinson's disease and dementia that develop, really closely in time, maybe over just a year. Parkinson's disease, there are all kinds of new diagnostic tests. You can get a skin biopsy now. There also is a kind of a PET scan for Parkinson's disease that's really only used in research. But again, the thing that people are really excited about is a blood test, which is in development. And the reason it's important is because people can develop symptoms of Parkinsonism without having Parkinson's disease for a whole bunch of other things, right? And so we need to differentiate those people who have Parkinson's disease from Parkinsonism Again, because, we have a variety of different approaches to trying to treat that abnormal protein that are in development. So in order to test those, we really need to know who has that abnormal protein. Is that the answer to your question?
helpful, yeah. Thank you so much. I regret our time is over, but please join me in thanking our panelists